Okay, this video is for section 9 for parametric equations. So these are, this section is brand new. These are going to be equations. I'm not going to say functions because a lot of them are not functions that have 3 variables. So these are what we are learning. Evaluate a set of parametric equations, graph them, rewrite them in rectangular form. Rectangular form means your plain old XY form that you're used to. Find the set of parametric equations for a graph. Okay, so what these look like and why we need them. So it says up to this point you have been representing a graph by a single equation involving 2 variables, an x and a y, right? So you had lots of equations which had x's and y's, all different kinds. And those I can call functions. Most of what we looked at were a function. In 9.1, we looked at circles. Those are also not functions because they fail the vertical line test. So you can think the circles and the parametrics often are not functions. In this section, you will study situations in which it is useful to introduce a 3rd variable. Most of the time, the 3rd variable is a t and it represents time. See the usefulness of this procedure, consider the path of an object as it is propelled into the air at an angle of 45 degrees. All right, so we have something going up and something coming down. So here is our graph, and here is our equation. So this equation is what you're used to seeing. Again, if you need to pause the video to take some notes, please do that. This is what you're used to seeing, an x and a y. So this is useful. It tells you, it starts at x equals 0, y equals 0. Looks like this is the high point where x is 36 and the height is 18, and then this would be when it's on the ground. So that's all fine and good. That you've been looking at since Algebra 1. Now, if you think about it, this equation does not tell you the whole story, although it does tell you where the object is. So I could figure out the x and the y and figure out where it was. But what I could not figure out was when was it at that point. So if you go back here, I know this is its position. Whoops, hang on. This is its position, but I don't know when it's at that position. I guess I could kind of assume that it starts here at time equals 0, but I really don't know when it is at all of those different positions. So that's where a parametric comes in. The 3rd variable, like I said, in this situation would be t, which would represent time. So this would tell us at what time is the particle at a specific position. So this function right here, which I could write as x with t being its input, would be that. So this would tell me, I could put any time in here. So I could say, well, when time equals 2 seconds, what is the x position? And then down here, this function y, which I could write as y of t, I could say, and its y position, or its up-down position at time equals 2, I could put time equals 2 in here. So this function would say where it is right-left, and this function would tell me where it is up-down. So at time equals 2, I could figure out where the particle is at. All right, so from this set of equations, you can determine that at time equals 0, the object is at 0.00. So if we went back and we put a 0 in right here, if we let t equal 0, and we let t equal 0, and we let t equal 0, we would get x equals 0 and y equals 0. It's very messy, but that's okay. You get the idea. All right, so, and so on. You can pick any time, plug it in, figure out the x position and the y position at a certain time. For this particular motion problem, x and y are continuous functions of t, which is why I wrote them as x of t and y of t. So t is your input, time is your independent variable. Time is always independent. And the resulting path we call the plane curve. Recall that a continuous function is one whose graph has no breaks, holes, or gaps. Okay, I think now we are going to graph one of these. Oh, no, we got a definition. So I would definitely put this into your notes. So this is definition of a plane curve. If f and g are continuous functions of t on the interval I, then the set of ordered pairs f of t and g of t is the plane curve C. So they're naming the curve C. The equations are given by x equals, so this is your x position, and y equals g of t. So this gives you your x position. This gives you your y position. They are each their own functions, and t is the input for both of them. So you'd put t into this g of t to find the y position, and you would put your time into f of t to find your x position. So this is how a parametric equation is defined. You'll always know it's parametric because you'll have these two functions and the input will be t. Again, pause if you need to. Okay, now I think we're going to graph one. One way to sketch the curve represented by a parametric equations is to plot them on the xy plane. That is what we're going to do. We're going to have certain values of t. We're going to plug them in, and we're going to find the x and y. Okay, example 1 is in your 9-4 note supplement. So it says sketch the curve given by the parametric equations. So this is our x position, this is our y position, and we're looking for a graph between the times of -2 and 3. So we're going to do a table of values, and it is going to have 3 columns. T is going to be our input. So we're going to do the times between -2 and 3. So those are our inputs. This is going to tell us our x position. So this is t squared minus 4. And to find our y position, I'm going to write that as 1/2 t, or you could write it as t over 2. Doesn't really matter. So if I substitute -2 into this function, I'm going to have -2 squared, which is 4. 4 minus 4 is 0. I like to do all the x's, and then I like to do all the y's, because then I'm working with one function at a time. If I substitute -1 in, I'm going to get -1 squared, which is 1. 1 minus 4 is -3. And I don't think I need to go through all this math. You are all, wait a minute, I have a mistake. Let's get rid of that. When x is 0, y is -4. When x is 1, or when t is 1, x is -3. When t is 2, x is 0. And when t is 3, x is 5. Oh, just for fun, I'll do y in a different color. Okay, so now our y position, when time is -2, and I put -2 into my y function, I would have 1/2 of -2, which is -1. Basically, I'm doing 1/2 of all these numbers. So this would be -1/2. Half of 0 is 0. This would be +1/2. Half of 2 is 1. And half of 3 is 1.5. Now, what I'm going to graph will just be the x and y coordinates like you're used to graphing. So we are just going to graph these coordinate points, x and y. The one important thing when you're graphing these is you have an initial point, which is where we're starting, and this would be at t equals -2, because that's where we're starting this at. They said from t equals -2 to 3. And then we're going to have a terminal point. So these begin and end. They don't go on forever. The terminal point will be when t equals 3, because our time interval is from -2 to 3. And we're going to have to include direction arrows. And I'll show you what those look like on the graph. So the first point that we're going to plot is 0, -1. So over 0, down -1. That is going to be our initial point, or our starting point, you can think about it at. And remember, that happens at time equals -2. So when time is -2, which seems weird, we are at 0, -1. The next point is -3, -1/2. So I'm going to go over -3, 2, 3, and down about -1/2. Oh, that did not work well. Okay, this board does not like to do a point, so I'm going to do that. So I'm moving in this direction. I started here, and then I went to this point next. So that is what I mean by a direction arrow. The next point we're going to graph is over -4 up 0. So that will be right there. And then over -3 up +1/2. Over 0 up 1. And over 5, 1, 2, 3, 4, 5, up 1.5. All right, so this is what my graph looks like. Doesn't want to draw for me. And this is the direction that I was graphing in. So those are the direction arrows. This is my terminal point. And that happened at time equals 3. So for each point on this graph, it also has a time associated with it. I don't like that arrow. There we go. So we can get 2 pieces of information, the position and the time that it happened at. All right, if you need to, pause the video, get all this in your notes, because I think, let me clear this, I think you're going to try one now. Oh, this is a prettier graph of the one we just did. And you can see on this graph, they labeled the times where everything was happening. So this is your initial point at time equals -2. This is at time equals -1. This point right there is at time equals 0, and so on. So you can get the position for every time. Okay. So now you're going to try one. This is also in your notes supplement. So you're going to do a table of values. We already have the time values filled in for you. If they weren't, though, you're always going to get those from the given interval that they give you for your time. This is going to give you your x position or right-left position of your particle. This function is going to give you your y or your up-down position. So step 1, table of values using given range of t values, which in our case is -2 to +2. Step 2, graph the position with arrows to indicate direction. So make sure you have direction arrows. So I'm going to say try this and try sketching a graph. I don't think we gave you a coordinate grid, but you can sketch that pretty easy. Your numbers shouldn't be too big. Pause the video and try that. Okay, you should have gotten something that looked quadratic-ish. So this is your table of values, and this is what your graph should have looked like. Somewhere on your graph, you need to have direction angles. these numbers did get pretty big. So if you graphed this point right here, that should be labeled your initial point, so where you're starting. And this on your graph, you would want to label your terminal point. But again, it was 18, so it wouldn't fit on this picture. Okay, what else do we have? Now, you can also graph parametrics in your calculator. So this is using a graphing utility to graph the curves. So you want to go into your settings. You know, when we changed them, did we ever change these before? I can't remember. You want to put it in parametric mode. Hang on. I am graphing. I grabbed a calculator. So I just want to tell you where you find this at. If you choose the mode button, it's right underneath the window button, and you go down to the, let's see, 1, 2, 3, 4, the 5th line. It says function, which is probably what is highlighted right now. And then the next one says parametric. I'm looking at my 84 right now. So you want to arrow over and choose parametric. That is how you will change your mode. And when you do that, so arrow over and then hit enter. And then if you go to y equals, like you're going to graph, you'll see that it has it set up for you to put in your x function and your y function. So it sets it all up for you to put in 2 functions. So again, mode parametric. So practice that right now and put in the first line, x1 of t. You would put in t squared. And you'll notice when you hit your variable button, it's going to put a t in there. It's not going to put an x. It's going to put a t. So put in your t squared. And in your y sub 1 of t, put in t to the 3rd. Okay, I think I have a graph in here. So if you graph that in your calculator in parametric mode, you should get something that looks like that. Notice this is not a function. Did it ask us to say if it's a function? Graph, use the graph and the vertical line test to determine whether y is a function of x. Okay, so they did ask that. So that's our graph. And this most definitely fails vertical line test. If I put a vertical line right there, it crosses my graph in 2 places, so it is not a function. All right, I think we're going to try another one. Try that one. That's your turn. Should be pretty easy. Just put it in your calculator, and you should get a graph that looks like this. This one is a function, so this one passes vertical line test. Therefore, remember, it is a function. All right, that's pretty straightforward. Okay. Oh, didn't have to write that. Got it right there. You try number 2. Try that one. Ooh, I forgot to mention setting your window. If you're having trouble with these graphs, try setting your window. I think when you're in parametric mode, you can set your time inputs. If we have some questions on that, I can go over that in class tomorrow. All right, let's see. You should get something that looks like that. That would also pass vertical line test. Okay. I think that is it for 9-4. This is a warm-up for probably the beginning of 9-5. There is a web assignment for 9-4. So I'm going to say 9-4 homework is in web assign. All right, that is it.